Today I want to discuss about haloalkanes and haloarenes. Before going to discuss about the haloalkanes and haloarenes in the preparation and properties of any haloalkane or haloarene, generally we will get the isomers and generally some reactions are involved that is called substitution reaction and elimination reactions. Therefore, first I will discuss about the isomerism and substitution and elimination reaction, because already in the first year you will study the isomerism up to structural isomerism and little bit about the stereoisomerism, that is geometrical isomerism, and some addition reactions also and little bit elimination also, but we'll try to discuss about here isomerism, that is stereoisomerism will focus here. So isomers or isomerism, we have the two type. One is a constitutional or structural. Second one is which one? Stereo. Therefore, this isomerism, it is how many types? Two types. One is constitutional, another is stereo. In this we have one is chain isomers, positional isomer, functional isomer, metamers, tautomers, ring chain isomers. Now I am not focusing on the constitutional isomer. I want to focus on the stereo isomers. So in stereo isomer we have two types. One is a conformational isomer, another is a configurational isomer. So in that first one, conformational isomer here, eclipse, student wrote wrong spelling. So that is called eclipse form. Another is a staggered, and next one is a skew conformation, gauche conformation. It is pronounced as a gauche. Spelling is Gauch, gauche. It is pronounced as a Gosh, gauche pronunciation. Keep in mind. Next, configurational isomer. In this, we have one is geometrical isomerism, another is optical isomerism. In geometrical, generally we'll focus on the cis trans isomer, syn anti EZ isomerism. Next, that already you maybe studied in the first year, that I'm not focusing on the geometrical, I am focusing on the configurational isomers. In the optical isomer, we have the one enantiomers, diastereomers. Diastereomer also can exist in the geometrical isomerism and optical isomerism. Cis trans isomers are generally diastereomers also. That's why don't forget it. Next one, in this we'll focus on the RS, that is absolute configuration or nomenclature. Another one is the optical activity. Then first one, what is the optical isomerism definition? That is the compounds which having the same molecular formula but they differ in configuration of atoms or group in three-dimensional space. In three-dimensional space. Now, what is the optical activity? So, ability of a compound rotate the plane polarized light, that is called optical activity. What is a plane polarized light? That we'll discuss. Now, this is a sun. Here in that name like this, I wrote here, my name is actually Ravi. Ravi means sun. That's why I wrote here, because in classroom I explain, this is actually whatever I explain, that notes only I'm now explaining this video. So therefore this is Ravi means sun. From the sun, this is light propagating or oscillating in all direction. So oscillation of the electrical field of the ordinary light occurs in all possible planes perpendicular direction of the propagation. So this is all possible direction. This is Nicol prism. Now, when this light is passed through this Nicol prism, then the light will be propagated in only one direction, that is electrical property respective. Then this is called plane polarized light, that is called PPL. When this plane polarizer passed through the, here we have the organic compound in the test tube, but I wrote normally here this dotted line is the organic compound. So when this plane polarized light passed through this polarimeter, then this light will be rotated due to the compound. Compound rotated the plane polarized light. Then here one, two, three, four possibilities are there. So first one possibility here observer I observe here. It means this is a person observing from this side. Then this is called left side. This is called right. So now if the plane polarized light, if it is rotate right side like this, then that is called uh, dextro rotatory right side rotation denoted with a plus sign. For example, here plus 15 degree rotated, then this is called uh, dextro rotatory or denoted with a small d. So this can be represented as a d or plus, both meaning same. This is called dextro rotatory. Next one, in this light is not rotated, which is dextro-rotatory. For example, in this dextro-rotatory, maybe right side rotated means optically active. What is this? Is optically active. Next one, in case light do not rotate toward the left or right direction, then only this is considered 0 degree optically inactive. That is called achiral. So keep in mind which is optical rotation is 0 degrees there, that is called optically inactive, and that is called achiral, which is optically active, that is called chiral. Okay, now next one, here in this second one is the optically inactive form. Here one is two, in two we have one and two, and again when the compound rotates the plane polarized light, this is a right side, left side equal magnitude. This is a minus 5, minus 10, minus 15, minus 5, sorry, plus 5, plus 10, plus 15, equal magnitude. So plus 10, minus 10, then mutually cancel 0 degree, therefore optically inactive. That is called racemic mixture or meso compound. So which will shows 0 degree. Another one possibility, what is that? That may be racemic mixture, otherwise that is called meso compound. Meso compound having the internal plane, half of the molecule rotate the right side, half of the molecule rotate the left side. Racemic mixture, what is there? One of the enantiomer rotates the right side, another enantiomer rotates the left side, equal magnitude, therefore optically inactive. Therefore, it is a optical rotation 0. Another one, if the plane polarized light rotated to the this left side to the observer, then this is like this left side rotated now. Therefore, this is called, you have to analyze this properly, then I denoted like this minus 20. So minus 20 degree laevo rotated optically active. So I hope you understood now what is the optical activity, ability of a compound rotated the plane polarized light. So the organic compound must be what is required, chiral required. Next one, to show optical activity, the compound must be what is a chiral, unsymmetrical required. So now some important terms are involved in the optical activity. One is enantiomer. What is enantiomer? This is very important for the board level and competitive level. The stereoisomer which are non-super imposable mirror images are called enantiomer. One example here taken, butane 2-ol. So N forgot student here. That's why some spelling mistake will be there because students are just learning stage. They don't know what are the exact spellings. So butane 2-ol. So butane 2-ol structure what is that? CH3, CH, OH we cannot up or down, and CH2, CH3. So according to this, one, two, three, four. Second position we have the OH group. Then this is butane 2-ol. Then we can draw this is called chiral. Around this carbon we have the different groups. One is CH3, OH, H, and this is total four different groups are present. Therefore, how to represent this is carbon, then OH, and this is away from the observer, dotted line CH3. This is called near to the observer, C2H5, and another one is called H, only H. So this is called mirror. In the mirror, which will be first appear, which is near to the mirror, that is first appear. Therefore, OH, and this is away, and this is called near to the observer, C2H5 ethyl group, and this is called hydrogen. When you rotate the second compound, this mirror image 180 degree, and observe that, then what you will get? This compound, meaning this will be exactly 180 degree. Therefore, we will get OH right side, and this will be dotted line becomes C2H5, and dark line becomes CH3. With model you can understand, normal is somewhat difficult. And take this one molecule and place on the first one, then it is not superimposable. Or take this one molecule and place on the first one, not superimposable. Reason, here OH is right side, here OH is left side. And if you take this one, OH is right side, here OH is right side is there, but here dotted line is methyl group is there, here dotted line is the ethyl group. Therefore, they are not superimposable on each other. Therefore, it is enantiomers. Next one, another word, what we can use here, asymmetric carbon or stereocenter. If all the substituent attached to that carbon are different, the mirror image of this molecule is not superimposed on the first one molecule. Such a carbon called asymmetric carbon or stereocenter. Now same example taken now here, all are different is there now in the butane 2-ol. This is OH, CH3, ethyl, H, all are different. Therefore this carbon is called asymmetric carbon. So asymmetric carbon or chiral center. So all these are different words will be used in the competitive level. Then you should be familiar with these words. That's why every word clearly mentioned here. Now carbon with the four different substituent. Carbon with the four different substituent and tetrahedral was given by, this is asymmetric carbon or chiral carbon. So the Dutch scientist Van Hoff and what is it, French scientist Lebel in 1874 they decided the tetrahedral geometry. So now what is the stereo center or stereogenic center? Stereogenic center, and some students they confused with the asymmetric or chiral carbon. Therefore, these words are very important. Stereogenic center are atom at which by exchange of any two substance gives a new stereoisomers. So now here I mention one example. What is the example? Carbon. Here 1, and here 2, and here 3, and this is called fourth group. Now I am exchanging any two group. What I am exchanging here? Carbon. Then here 1 as it is there, and this is 2 become here, this is exchanging. Then here 2, here 3, and this is the fourth one. Then if it is R configuration, just I'm not taking all priority, just one example. Anyway, clockwise is there R configuration, and this is a become S configuration. Then we are getting a new stereo isomer that is called stereo center or stereogenic center. A stereo center word used for asymmetric carbon and a double bonded cis trans isomer that already I explained in the previous. So keep in mind cis and trans isomers also stereo centers, because if you take this one example, carbon double bond carbon, these are hydrogen, this is a anyone consider methyl group, and here carbon hydrogen, here methyl group. Then what we are getting here, this is we are fixing methyl and double bond, then here we are exchanging methyl and hydrogen, now we are getting the transform. This is which one? Cis form. If we get a new stereoisomer, that is called a stereo center. So I hope you understood what is the stereo center. Chiral, achiral word given. Achiral mean what is a symmetrical or homomers. Words are very important. You have to focus on these words. Now propane 2-ol. Now keep in mind in propane 2-ol. The propane 2-ol. Prop N2-ol. This can be represented as CH3OH CH3. In this, we have carbon OH. One is away from the observer methyl group. Another one is near to the observer CH3, and this is normal H. In the mirror, this will be appear as OH, and this will be CH3, and this will be a near to the observer dark line CH3, and this is normal hydrogen. Now these are look like not mirror image to each other, but just to rotate this is 180 degree. Then what you will get? This will be carbon OH, and here anyway both are methyl is there, therefore this one is become as a methyl, and this is again methyl, and this is H. Take this one exactly place on this one, then superimposable. So which are superimposable? They are called achiral. Which are non superimposable? They are called chiral. So now every object has its mirror image. One, if objects which are superimposable on their mirror images are called achiral. Keep in mind achiral meaning what is that? The mirror image which is superimposed on its original structure, that is called achiral. Next one, chiral. What is a chiral meaning? Unsymmetrical. In this unsymmetrical, if objects which are non-superimposable on their mirror images are said to be chiral, and this property is called chirality. So now whatever the different word we discussed, now all together I mention here. Now keep in mind this is a carbon, around this one is methyl, ethyl, bromine, hydrogen. All four groups are different, that is called asymmetric, because if you cut this molecule you will not get the any equal parts. Okay, so that is called asymmetric, and also known as what is that? Chiral, chirality, also known as what is the stereo center, because if you exchange any two groups you will get the new stereoisomers. Now this is nitrogen. Around this propyl, ethyl, methyl, isopropyl, all four groups are different. Therefore, this is also called asymmetric, but that is nitrogen, and that is also known as a chirality, and also known as stereoisomer. But keep in mind these isomers. These are cis-trans isomers. Which one is a cis-trans isomer? Cis-trans isomer, if you exchange two groups, then you will get another trans isomer. Therefore, these are called stereo isomers. Stereo isomer word, stereo center word used for which one? All these are stereo centers. And next one, chirality word used for which one? Which are non-superimposable. So we can say these two are chiral, actually up to, which is star mark is there, that is only chiral. So it's shown up to cis not. That's why keep in mind star mark star, that is only chiral. And this is actually uh, not asymmetric carbon because it's only first one. So students when they write from the back benches not appear properly mean they will do some mistake. This is only asymmetric carbon. So this red line for only this one, and this black line for both the star marked. Here star is a red color, that's star mark, and stereo center for all this one applicable. And this is which one? What is that? Achiral. Achiral means any two groups are same in, that is compulsory plane of symmetry present, and its mirror image is superimposed on the original structure. That's why achiral. So this is carefully you have to observe. First one asymmetry, and these two are chiral, chirality, and all these are stereo center. Stereo center word, not what do you call it? All chiral centers are stereo centers, but all stereo centers are not chiral because these are stereo centers. Round of mark which is there here, circled. Here word mentioned circle, 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 circle. So these are which one? Stereo centers. That's where all stereo centers are not chiral center. Keep in mind. Next, enantiomers. Enantiomer already we discussed, but their property little bit we will discuss here. Enantiomer possess identical physical property in an achiral medium like melting point, boiling point, refractive index, density, etc. But they differ in rotation of plane polarized light. When their bonding is similar, therefore they shows the same melting point, boiling point, and refractive index, but little bit not little bit compulsory they shows the difference in the rotation of plane polarized light. So here I taken 2 bromobutane and this R configuration, this is S configuration. So R2 bromobutane, S2 bromobutane. Boiling point in degree Celsius. Here degree forgot. So 91.2, here 91.2. Melting point also in degree Celsius, minus minus, same is the refractive index. This is without any units. Density gram per milliliter. So 1.253, 1.253. But rotation of plane polarized compulsory different. So in one of the short I explained that R configuration means don't consider deep, and S configuration don't consider levo rotatory. So it may be R mean maybe levo or dextro rotatory. Any one possibility is there. Next one, optical activity. In this optical activity, so optically active or inactive, how to identify from a given compound, so that we can identify. First one, condition to show optical activity. Roman letter 1, optically active solution contain 1. What is that one? A chiral compound or chiral molecule. First one, what is required? Chiral. That's why here gap is there, a chiral. If you write together a chiral, that is symmetrical. That we don't want. We want which one? A chiral. This is we don't want. Chiral meaning what is that? Like this. All four groups are different with the star mark, generally denoted that is asterisk. Then next one, in this one, A is it. A compound with the one chiral center is always optically active because there is no any meso compound possible in this one. That's why one chiral center is there. Then always optically active. Keep in mind, always optically active when one chiral center like this present. Next one, a compound with the more than one chiral center, it may or may not be optically active. So why it is may not be optically active, we'll see the examples. So now second one, optically inactive solution. Optically inactive solution meaning what is that? It may contain one achiral. Achiral meaning what is that? Any two groups present same in compulsory plane of symmetry present. Therefore what is called achiral. In and some few exception word given meaning. What is that? Any two groups are not same or chiral center also not present, meaning they are optically active like this allenes and biphenyls. So what we are thinking that chiral center present only optically active. Some are without chiral center also they are optically active. There's a few exception word given. Now question, which of the following compound is optically active? Hint here, chirality is required. To identify chirality, check the following. What are the following? Symmetry elements. So we know the symmetry elements. What are the symmetry elements? One is plane of symmetry, second one is center of symmetry, third one is axis of symmetry, fourth one is alternate axis of symmetry, SN. But for checking for NEET level, J means level, we'll use the only plane of symmetry and center of symmetry. That's why here I focus on these two. All are actually used, but mainly we are focusing on the plane of symmetry and center of symmetry. So now the symmetry element absent in all the conformation. In case conformations are present, in all conformation that must be symmetry element absent required. In any one of the conformation may be plane of symmetry or center of symmetry present in, that is optically inactive. Then how to check for this? I made one short in that we can observe that first we have to select this most symmetrical form, in that maybe plane of symmetry present or not, that you have to check. And compound is chiral, symmetry element absent in the all conformation, that compound is chiral and that is optically active. So now, so we are taking that what are the few exceptions? Allenes. Allenes mean what is the carbon-carbon double bond adjacents are present. So carbon-carbon meeting at the a single point, that is single point. This is, so that is called a, what do you call this is cumulated isolate, cumulated alkene. This is what do you call this is cumulated alkenes are called generally allenes. So now I am taking this here methyl, methyl, you want here separate meaning, carbon double bond, here hydrogen, this is methyl, and here methyl, and here hydrogen. So this is not look like this. This is how it look. One is here shown. Here care, these alleles are shown clearly. So this double bond R, which one? Like this carbon. First bond in case it is vertical, meaning as it is like this. Here hydrogen also vertical, and this is also CH3. In next double bond is horizontal, mean this is away from the observer, that's why dotted line will be there. This is near to the observer, there's a dark line represented, and this is near to the observer, therefore methyl near, and this is which one? Dotted line, this is hydrogen. So somewhat it is difficult to imagine on the paper or board. You have to analyze this is by using any model, then it is perfect to understand. So but keep in mind vertical is there, meaning uh, cutting equal part. If you cut this hydrogen, hydrogen equal, methyl equal, and this double bond also equal. But if you cut like this is the dotted away from the observer, this is near to the observer, and these two are not mirror image to each other. These are not mirror image to, but this part is mirror image to each other. So overall molecule plane of symmetry absent, center of symmetry absent when these are different group at this one. In case any one side, keep in mind any one side, both are same groups are present, 100% optically inactive because plane of symmetry present. That's why here clearly you have to understand. So in this case here absent, absent is there, therefore optically active. And now in case three double bonds are there, here how many double bonds? Two double bonds are there, one two, three double bonds are there, mean middle one is vertical and left and right are horizontal, that is shown here. So in case like this is there, mean plane of symmetry possible. So here student wrote maybe wrong, this you consider here, this is vertical, vertical, and this is horizontal, vertical, horizontal. Then geometrical isomer possible, GI possible, but optical isomerism not possible. Geometrical isomerism possible. So here, like this question will ask, Allin shows the two types of isomerism in case even number of double bond. Keep in mind, even number of double bonds are present, meaning with a different group. Keep in with a different group, optical isomer shows. If odd number of double bonds are there, odd number of double bond, then geometrical isomer possible and optical isomer not possible. Keep in mind. So now here taken any two groups are same is it in the any one end, then compulsory what is there? If you consider this a horizontal, this vertical, then plane of symmetry present, therefore optically inactive. Now one more example. These are called spiro compound. Spiro compound explanation is similar to which one? Alene style. So two rings are joined at the one carbon. Then here also, if any two groups are same here in the any one end, that is optically inactive. Compulsory both side different groups are required, then only optically active. And in case odd number of rings are present, it shows the geometrical isomer. So here one, two, three rings are present. Therefore, achiral optically inactive because plane of symmetry present, and it shows geometrical isomerism. Similarly, biphenyls with the substituted biphenyl. If smaller groups are present, biphenyls are optically inactive. In case larger groups are present, mean optically active. For example, this is a biphenyl. Then here I am taking the fluorine, hydrogen, and what is called this is a fluorine, hydrogen. Then these are very smaller, that's why there is no much restriction, that's why easily can rotated plane of symmetry present, that's why smaller groups are not considered at ortho position of the substituted biphenyl. Compulsory larger groups are required, therefore now here took the bromine are larger size, iodines are larger size. Due to that larger size, they will feel some repulsion, electronic repulsion, that's why this is one is here shown clearly. This dark one shows meaning a horizontal near to the observer and is not shown meaning a this vertical. So you keep in mind vertical meaning you put the two hands, one is horizontal and this vertical fingers, then you will get there. So horizontal vertical only exist, both are vertical both are horizontal not exist because due to electronic repulsion. So here this staggered form, this is staggered form, not convert into this one here actually to not represented, this is not convert into this one because both are vertical is there or horizontal type is there, repulsion like this not exist. And here now this side this is horizontal, this is vertical. Now this side this is called vertical, this is horizontal, this will also not convert into this form, therefore here, too crowded, impossible, not exist. Therefore, achiral optically inactive. Then it is atropic, not a atrop isomerism. This is atrop isomerism. Students not read properly. That is small different. What do you call mistakes will be there. So this is a. These are called staggered forms. Staggered form. In this one, sigma absent, Ca absent. Therefore, optically, which one these are? Active, optically active. Now I am taking one more example here. This is called cyclooctene. This is called cyclooctene. Which form this is? A cis form. So generally cyclic alkene exists in the cis transform from the 8 carbon atoms. That's why cyclooctane taken. Cyclohexene cis form not possible because due to ring strain trans not possible. Cis only possible trans. But geometrical isomers are relative to each other. That's why we cannot tell cis. When trans is possible, then only we have to tell the cis. Therefore, this is not possible in the cis trans isomerism. Therefore, cis isomer, this is plane of symmetry present, optically inactive. Achiral, this is. Achiral means what is it? Optically inactive. But transform is exists like this. Its mirror image. Both are not superimposable. Cis, what do you call sigma absent and CI absent means plane of symmetry, center of symmetry absent, optically active. So this is somewhat difficult. It is cis form generally twisted form. This is which one? This is a twisted. Then next one is a meso. Meso compounds are important for board level. A chiral molecule having more than one chiral center. Already I told you that one chiral center will always optically active if more than one chiral centers are present, which is optically here meso compound optically inactive. More than one present may not be active. Now in this case, inactive, that is called achiral, as a rotation due to one half of the molecule will be exactly cancelled with the another half of the molecule. This is called internal compensation. Internal compensation meaning what is that? One rotation is right side mean another is left side, so mutually cancel each other. That is called internally, not externally anything added. So meso isomer is optical isomer but optically inactive. Now I am taking one example here. Meso isomer, optical isomer but optically inactive. Now we have taken one example 2,3-dibromobutane. Then we have one planar symmetry and these are bromine mirror image, CH3 mirror image, HH mirror image. Internal plane present, sigma present. If it is rotated the right, what do you call this is right side, this is a left side. Here arrow mark should be present. So this is left side. Then minus 10 and another is plus 10. Totally achiral, optically inactive. Now, this is also its mirror image. So its mirror image is not considered because these two are same, identical. Identicals are counted one time only, not two times. Therefore, meso compound always only one exists. Only one meso exists, not its mirror image. Keep in mind. For meso compound, its mirror image not counted. Already here clearly mentioned they are identical. Therefore, one time only counted. Keep in mind. Now these two are another example I took here. Look like this is bromine, chlorine, mirror image, chlorine, dotted line, bromine, dotted line. These are identical mirror image. Look like what is that? They are mirror image to each other but not superimposable, because if you take this molecule and place on this one, here dotted lines are there, here dark lines are there, not superimposable, look like. But what you have to do, rotate this compound 180-degree, then you will get what is that? These are comes right side, therefore chlorine or bromine. What you will get here exactly? Mm, this one side you will get bromine and this one side you will get the chlorine, and this one dotted line chlorine, and this one sorry dotted line bromine. In any mistakes just you cover it, but actually 180 degrees same possible. Therefore these are identical structure. Racemic mixture or racemic modification or conglomerate. So these are called racemic mixture or racemic modification. Now I am taking one example. What is this example here? Uh, 2 bromo 3 chlorobutane. Now, here RS nomenclature you don't know, but here I explained previously. So here this is a S configuration, this is R configuration. Here R configuration, these are S configuration. S mirror image is R mirror image is S. Keep in mind. S mirror image, R mirror image is S. These are mirror image to each other, mean enantiomer. But take this molecule and place on the first one, not superimposable. If you rotate also 180-degree, not superimposable. Therefore, these are called enantiomers. Keep in mind after 180-degree rotation also these are not superimposable, therefore these are called enantiomers. Now taking tartaric acid, in the tartaric acid what we have, plane of symmetry present for this isomer. So this is called meso. Its mirror image not counted, therefore not considered another time, only one time. Now I can write, so this is not mirror image now. These are not mirror image to each other. So here OH, OH, here H, not mirror image. Therefore, these two are different dash stereomers. Now these two are which one? OH, OH, H, H, mirror image to each other, and these are enantiomers. So this is non-superimposable. These two are. Now I will give the number 1, this is a 2, this is a 3. Or A, B, C, already I given A, B, C. So A, B, C. These two are which one? Not mirror image and not superimposable. Therefore, these are called dash stereomers. These two are which one? Mirror images. Here not either, but here only which one is a mirror image and not superimposable. This is okay. Therefore, these are called which one? Enantiomers. Here word clearly mentioned enantiomers. So this rank shortcut is there that you don't know. That's why I'm not discussing here. That is useful to identify RS nomenclature purpose. That is a different. Leave it there. So keep in mind, based on this, already I told you that R mirror image is yes and yes mirror image is R. Then these are called which one? Enantiomers. Or vice versa. S mirror image is R mirror image is S, vice versa. Now, dash stereomers meaning what is that? R, yes, then here R, another is R. So these are mirror image to each other, but this is not mirror image. Otherwise, this may be considered for a R mirror image, what is that? Yes. But here, as it is there mean what is called not mirroring. So in this compound, two chiral centers are there. So first chiral center R, second chiral center R. But here in this mirror image, R mirror image yes is there mean okay, but here same is there mean this is called dash stereomer. Otherwise, if you take yes mirror image is R and yes mirror image is yes only, then this is called dash stereomers. Keep in mind R mirror image yes mean enantiomer. Yes mirror image is R mean enantiomer. R mirror image R mean identical. Yes mirror image yes mean what do you call identical. But if more than one chiral centers are present, then that time this is diastereomers. Keep in mind. So now I took here one example. This is same tartaric acid, but in the wedge dash formula. This is then this is sigma is present meso compound. Same this A form, this B form, this is C form. So now these are R yes, R. Here also RR is there. Then RR and here yes yes. Then here also yes yes. So students should know the all different form. Which one is a Fisher projection? This is a wedge dash projection. Therefore, students should not confuse in the examination how to identify the RS nomenclature. That purpose I explained. In case you are unknown that RS nomenclature, somewhat difficult. This is the rules are separate. Later, in case is there, I will discuss. Next, now I given here A, B, C, D, E, F, G, H, I, and G. So one I took here. What is this here? Chlorine, methyl, bromine, H. This is R configuration, for example. Then what I did here, chlorine, methyl, vertical line as it is there, not changed. What I changed now, horizontal. Horizontal means 180-degree change. Therefore, R configuration become which one? Yes. Then these two are which one? Enantiomers. Now, here 90-degree exchange. In the 90-degree exchange, what is there? First one, H methyl same is there. Methyl methyl same is there, hydrogen, hydrogen same is there. These two are changed. Keep in mind these two are changed. So how much 90 degree changed? 90-degree exchange is generally not acceptable because it gives which one? Yes, configuration from this to this. Identical this is. When you want to change anything that should give any other isomer meaning acceptable from this to this exchange because here sorry from first one. So these two are enantiomer and this C is from the first one, which one 90-degree action not acceptable, and then D is here methyl group, which one this is chlorine as it is there, and this is hydrogen, this is methyl, this is bromine. So which is fixed here? Chlorine is fixed, and these are clockwise or anti-clockwise. No, no, chlorine fix is there and these only exchange. Chlorine bromines are fixed. Again here 90-degree exchange not acceptable. Then here S mean here also S is there. Now here methyl, high chlorine, hydrogen bromine. Hydrogen bromine horizontal same is there from the first one. Then these are exchanged. How much? 180 degree. So this R mean this is which one? S. So from this these are acceptable. But from these three are not acceptable because these are identical, identical, identical is there. Now methyl group, hydrogen. So hydrogen which is fixed, bromine fixed is there, bromine, and these are clockwise change. Then R only. Then it is identical. Which one? This is identical. Now here which is fixed, bromine fix is there. Again this is clockwise from this one. Again you are getting identical. Next here R config which is fixed here, chlorine, bromine, hydrogen. From this hydrogen fixed and remaining are anti-clockwise changed here. So here methyl is a methyl and here chlorine and here bromine. So anti-clockwise from the G. H is we are getting from the G hydrogen fixed and these are anti-clockwise. So this is again identical, identical, identical. So here meaning what is there? From the first compound we are getting the S configuration by exchange of the 180-degree only one exchange. Two exchanges are doing meaning again you are getting identical. So which is not acceptable from the first one structure if you are getting the other configuration not acceptable. From first one you are getting the same R in R, that is acceptable. Any rotation you are changing and you are getting identical structure meaning acceptable, which is giving other configuration that is not acceptable. So overall meaning of this one, keep in mind R become yes not acceptable, R become yes not acceptable, R become yes not acceptable. That's a cross mark, cross mark, cross mark is there, and this is also cross mark not acceptable. But from this R, all these are acceptable. So that's a tick mark, all are given mean these are acceptable. So overall conclusion what is there? Keep in mind one 180-degree rotation not acceptable and second one is 90-degree rotation also not acceptable, but acceptable which one? These are not acceptable. Acceptable which one? 180-degree rotation two times acceptable because it gives the same configuration, and any one group is fixed, any one group fixed, and three are clockwise rotation or anti-clockwise rotation acceptable. It gives a identical structure. Keep in mind. So I hope I clearly explain all the things. In case any doubts are there or how to do videos on which topic you want the videos, also mention in the comment section. I will explain if the notes are available. I hope I explain properly all the concepts. Any mistakes are there, you mention here. I will correct it. Thank you.